Welcome to the deep dive. Today, we're focusing squarely on, what feels like a developer dream, right?
Absolutely. Building native apps for everything Android, iOS, Mac OS, Windows, all from one code base.
Exactly. We're diving into .NET MAUI, that's multi-platform app UI. We've got some really detailed technical material here, and our mission, essentially, is to pull out the core ideas.
Yeah, the breakthroughs in architecture, the practical stuff developers need to know.
So you can get a handle on this framework without, reading a novel's worth of docs.
And it's important to remember, if you've worked with cross-platform tools before, you know the promise doesn't always match reality. There are often trade-offs.
Complexity, performance hits.
Right. MAUI comes from Xamarin. Forms, it's the evolution, but it's more than just a new version number. It's a fundamental rethink, architecturally speaking, aimed at smoothing out those old friction points.
Okay, let's start there. Let's unpack that core advantage. For years, the biggest headache, I think everyone agrees, was managing all those separate projects.
Oh, definitely. Yeah. An iOS project, an Android project, Windows, even when most of the C# logic was identical.
Total nightmare for maintenance. So what's the single biggest thing MAUI does differently to fix that mess?
It's got to be the single project structure, hands down. That's the foundation.
Okay.
Instead of that juggling act, multiple platform-specific projects in your solution, MAUI pulls everything together. All the targets, resources, code into one project file.
One file.
Well, one main project structure. You just pick your target platform from a dropdown. It dramatically simplifies configuration, setup, maintenance, everything.
Just managing the files alone sounds like a huge win. But okay, cross-platform. The elephant in the room is always performance.
Always.
Everyone claims better performance. What do our sources say about how MAUI delivers? How is it actually faster than, say, Xamarin.Forms?
The sources do point to real, measurable improvements. Things like better rendering, faster app startup times.
Okay, but how? What's the mechanism?
It seems to stem from a couple of areas. One is just modernization, using newer controls, modern graphics APIs. But the big one, technically, is moving away from the old renderer system. We can get into that more.
Right.
And for the developer day-to-day, hot reload for both the XML UI and the C# code, that's a massive speed boost for iteration.
Yeah, no more restarting the whole app just to tweak a margin. That's huge.
Exactly.
Okay, you mentioned moving away from renderers. Let's dig into that architectural shift. If I'm writing my C# and XML in this single project, something needs to translate that common code into a native iOS button or a native Windows button. In Xamarin, that was the job of renderers, and they could be problematic, a bit heavy, sometimes fragile.
Yeah, they definitely had their issues. Lots of abstraction friction, as you said.
So what's the new magic? What does MAUI use instead, and why is it better?
The key technical innovation here is handlers. They are the replacement, the successor to renderers. They perform that translation layer function.
Handlers. Okay, so how do they avoid the problems renderers had? You mentioned friction, performance bottlenecks.
It really comes down to the contract, how they interact with the native controls. Renderers were pretty monolithic. They were responsible for everything about the native control.
Yeah.
Customizing them often meant rewriting a lot, which was slow and complex.
Right, I remember that pain.
Handlers have a much cleaner, sort of thinner interface. Think of it less like a translator dictating the entire native controls behavior and more like a focus pipeline, just mapping specific properties.
Oh, okay. More targeted.
Exactly. When you define, say, a MAUI label, the handler just maps that abstract definition directly to the platform's native label control, UI label on iOS, text block on Windows, etc.
And this cleaner mapping.
It reduces the complexity of the abstraction itself, which helps speed up rendering. And crucially, it makes platform-specific tweaks much easier. You typically only need to modify or augment the specific part of the handler dealing with the property you care about, not override the whole thing.
That makes a lot of sense, sort of decentralizing the translation work. So the app starts with MAUI, handlers map the UI. How do developers actually build with this? We know XML's there, but what about common patterns like MVVM?
Flexibility seems key here. MAUI fully embraces MVVM model view model. That's obviously huge given its popularity in the .NET world for separating UI and logic.
Right, familiar territory for many.
But interestingly, it also supports the MVU pattern model view update.
MDU, that's more aligned with paradigms like React or Flutter, right?
Sure.
Functional declarative UI.
Precisely. It's gaining traction. Supporting both lowers the barrier to entry, lets teams choose what fits best. With MVU, Often using C# and helpers from the community toolkit, your entire UI state can be driven by a single immutable model. Update the model, the UI automatically reflects the changes.
Okay, so options for different development styles. And digging deeper into modern practices, the sources mention built-in dependency injection, DI. Why is having DI baked right into the framework so important for cross-platform?
Well, if you're aiming for that single code-based stream, you absolutely need a clean way to handle dependencies. Think about services that need platform-specific implementations, like accessing the camera or GPS.
Yeah, the implementation is different on iOS versus Android.
Exactly. DI lets you register these services centrally, maybe defining an interface in your shared code and registering the specific platform implementations. Then you just inject the interface into your view models, pages, even your handlers.
And that keeps your core logic clean, platform agnostic.
Totally. It boosts testability massively, promotes reuse, and just makes the whole thing more maintainable across all those different OS targets.
Okay, so the architecture really pushes for structured modern development. Let's shift to the developer's daily grind. You're building pages, wiring things up. How does data flow? How do you move between screens?
For data, as we mentioned, MVVM is front and center. You've got robust data binding.
Right.
And not just simple one-way stuff. We're talking proper two-way binding, keeping UI and data in sync automatically. Command binding for user actions, like button clicks mapping to methods in your view model. And observable properties, so the UI reacts instantly when the underlying data changes.
Standard, powerful MVVM features. Now, navigation. That can get surprisingly tricky in cross-platform apps. Trying to make, say, a mobile app's tab bar feel natural, but also have it work reasonably on a desktop app with maybe a sidebar?
Yeah, consistency across paradigms is tough. MAUI's answer here is shell navigation.
Shell. Okay, what does that give you?
Shell is basically a higher-level abstraction for app structure and navigation. It simplifies defining things like flyout menus, like hamburger menus, bottom tabs, and the overall navigation stack. It uses URI-based routing, making it easy to navigate programmatically.
So it handles the common patterns consistently?
Yes, it smooths out those platform differences for the common scenarios. You define your app structure within Shell, and it takes care of presenting it appropriately on each platform. You can still do modal pop-ups or more complex custom navigation if you need to, but Shell provides that baseline consistency.
Got it. And the UI building blocks themselves, are developers using familiar controls like grid and stack layout?
Oh, absolutely. Grid, stack layout, flex layout. Those common layout containers are all there. But what's important is the native integration. Things like gestures, animations, touch interactions. The framework aims to translate your cross-platform definitions into smooth, native behaviors without you having to write tons of platform-specific code for it. That native feel is crucial. Which brings us to maybe the biggest challenge, accessing device-specific features. How do you let developers use the phone's camera or the GPS or specific sensors while still keeping most of the code shared? MAUI tackles this with primarily two strategies. First, there's a set of device APIs. These are cross-platform C# APIs provided by Microsoft that abstract common device hardware. Need the GPS location? Call the MAUI geolocation API. Need to check network connectivity. There's an API for that. MAUI handles calling the underlying native Android or iOS or Windows APIs for you.
So for common stuff, there's usually a built-in abstraction.
Right. But what if you need something really specific, maybe a platform-unique feature or a third-party native SDK that only exists on, say, Windows?
Yeah, the escape hatch. What do you do then?
That's where conditional compilation comes in. You use standard C# preprocessor directives.
Like hashtag if Android or hashtag if iOS.
Exactly. You can wrap blocks of code with these directives. So 95% of your code might be shared in C#, but for that one specific piece, you write hashtag if Windows and put your Windows-specific logic inside. Or then maybe in hashtag LSiOS for the iOS version. The compiler only includes the relevant block for the platform you're targeting.
So you can write platform-specific code, but it's contained and clearly milked within your single project.
Precisely. It lets you maintain that single code base while still having the power to drop down to the native layer when absolutely necessary.
Okay, this is great. Let's pivot to some really practical advice. Performance isn't just about the framework's architecture, it's also about how you write your code. What are some key optimization tips the sources highlight for MAUI devs?
Yeah, absolutely crucial for shipping a slick app. The sources point out a few key things. First one, for displaying lists of data, especially potentially long lists, strongly prefer collection view over list view. Collection view over list view. Why the distinction? I remember list view could get sluggish on mobile sometimes.
Exactly. Collection view is the more modern control, built with performance in mind from the start. It uses UI virtualization much more effectively.
Meaning it only renders what's visible on screen.
Right. It efficiently creates and recycles the visual elements for items as you scroll. List view. Well, it works, but it doesn't have the same level of built-in virtualization sophistication, especially for complex items. Collection view generally gives you much smoother scrolling with large data sets. Okay, solid advice. Use collection view for lists. What's number 2?
Number 2 is about your layouts. Be mindful of nesting depth and complexity. Avoid excessively deep hierarchies of stack layouts inside grids, inside other stack layouts.
Layout complexity kills performance.
It really can. Every nested layout adds to the measurement and arrangement calculations the UI system has to perform. Keeping your layout structure as flat and simple as possible helps speed up rendering, especially initial page load.
Makes sense. Keep it simple. And the third optimization nugget, this one sounds a bit more technical. Yeah, this one's important. Use compiled bindings in XML whenever possible. Compiled bindings. Okay, what's the benefit over regular bindings?
Traditional data binding often relies on reflection at runtime to find the properties on your view model and connect them to the UI. Reflection, while flexible, has a performance cost. It's relatively slow.
Right.
Compiled bindings shift that work. The binding expressions are resolved and validated at compile time. The compiler generates intermediate code that directly accesses the properties, bypassing the runtime reflection lookup entirely.
So it's just faster execution at runtime because the lookup work is already done.
Precisely. It removes that reflection overhead. For UIs with lots of bindings, especially inside lists or complex templates, this can provide a noticeable performance boost. Plus, you get compile time checking, catching binding errors earlier.
Those are 3 really concrete, actionable tips. Collection view, simplify layouts, use compiled bindings. Excellent. Briefly, what about things like app lifecycle and testing?
Pretty standard stuff, really. MAUI apps follow the typical platform lifecycles. On mobile, you've got your onStart, onSleep, onResume methods to handle state changes. On desktop, it's more about window events. For testing, the sources stress a layered approach is best.
Meaning?
Unit tests for your view models and services your C# logic. Use standard .NET testing frameworks like XUnit or MS Test for that. Then for the UI itself, you need UI tests. Tools like Appium or the specific MAUI.UI test framework let you write tests that actually drive the UI on each platform to ensure it looks and behaves correctly everywhere.
Makes sense. Unit tests for logic, UI tests for the cross-platform visuals. And finally, you built this awesome single code-base app, getting it out to users. Deployment.
The ecosystem support seems quite mature there. MAUI integrates well with CI/CD pipelines. Think Azure DevOps, GitHub Actions. You can automate your builds, tests, and deployments.
And publishing to the stores?
Yep, supports all the major ones. Apple App Store, Google Play, Microsoft Store for Windows apps, and standard macOS app distribution methods. It handles the specific packaging and signing requirements needed for each platform target.
Okay, that's a huge amount we've unpacked. We've seen how that single project structure, powered by the more efficient Handler architecture, is really the core of MAUI's promise.
Yeah, and the support for both MVVM and MVU patterns, plus built-in DI, provides a really solid foundation for building maintainable apps.
And those optimization tips, collection view, simpler layouts, compiled bindings, those are gold for anyone actually building these apps. The big takeaway feels like a serious reduction in code duplication and easier long-term maintenance.
Absolutely. And the vision, looking at the source material, is clear. Keep simplifying native development. Make it so you don't need to be an expert in Swift, Kotlin, WinUI, and AppKit separately. The goal is to master the unified framework. Which leads us to our final thought for you, the listener. If a single C# code base, using a framework like MAUI, can truly deliver high-performance, genuinely native experiences across iOS, Android, Windows, and macOS, what does that imply for the future?
Does the need for highly specialized, platform-specific UI teams start to fade? Does expertise shift entirely towards mastering the framework itself rather than the intricacies of each underlying OS?
Something to think about. That's all for this deep dive. Thanks for joining us.